Okay, so for the task number 9, what we are going to do now is we are going to get to load the same data. So from the task number 8. So this is the evidence from the task number 8. So we got some sample data, and then we have plotted the data in the task 8, and then in the task 9, what we are going to do is we are going to build a histogram of the probability density. Okay, so here we got a new function for you. Okay, so the way to work for it is you can Google for NumPy histogram, and it will show you how to use this function. Okay, so here in NumPy the histogram, what they need from you is they need an array of data, which is the sample data that we did in the last tutorial, and then we need the number of bins, or the number of, it looks like the number of points in the histogram, and you can also choose whether you want your histogram to be normalized. Okay, so if you normalize your histogram, that means you are going to have the total probability of 1. Otherwise, you're just going to count the number of points. Okay. Okay. So now let's have a go at this. So I will start with p bins. So here I have typed 2 values because from the manual, if you go down to the part returns, so this means that this function, okay, this histogram function will output 2 values for you. So it will output the values of the histogram, and it will also output the bin edges. Okay, so what are the bin edges? So for example, if we have a look at a histogram, okay, so in a histogram, yeah, here for each of the rectangles here, we call this a bin, right? This is a bin: 1 bin, 2 bin, 3 bin, 4 bin, 5 bins. Okay, and then the bin edges, yeah, it would be these values. Okay, so in this case, the bin edges will be 100, 150, until 350. Okay, so your program, yeah, will output these values. Okay, so that is the bin edges, right? So here we will do the np.histogram, and then we will input the sample data. Okay, so this sample data that you have was an array of about 10,000 numbers. Yeah. So sorry, it should be histogram, and then I will specify the number of, firstly specify the number of bins to be like, let's try 10. Okay, and then let's run the program. Oh, sorry, this should be with s, so bins, yeah, equals to 10, and then the p is the array of the histogram value. That means in the first bin, from 10,000 sample points, you get 7 sample points in that bin, and then you can see like the maximum numbers of points. You have about 2,800 points, yeah, in the histogram. So this is what you have, just look like a histogram like this. And then for the bin edges, if you type the bins here, the bin edges, it will show you the numbers from minus 3.92 to minus 3.8 to plus 3.8 something. So that means if you are going to draw a histogram, your first number from this picture, your first number will be that number minus 3.92, and then your last number from the bin edges is 3.878. it would be the last number here. Okay, so now we are plotting the graph of our own. Okay, so if so we need to notice the properties of this array. So if I type len p, that will show you the length of the array, or the numbers of the elements in this array. So here you have specified 10 bins. So if you type length p, you're gonna get 10 numbers. But then if you type the length of the bins, so you are going to get 11, because here you get the 11 values because of you have 11 edges. So for example, if you look at this histogram, you have 5 bins in this histogram, but how many bin edges that you have? You have 1, 2, 3, 4, 5, 6. You have 6 edges instead of 5. Okay. So then, if you try to plot the histogram, firstly, if I just try something like plt.plot, and then we input the bins and the p, or the probability, and you try to run this, you're gonna come up with the error for sure, because they say that x and y must have the same first dimension. So the error happens because you don't have the same number of dimensions. You have 10 and 11. Okay, so how can you fix this? Okay, so you can fix this by getting the values from the left hand side of the bins. So 100 and then until 300 to be averaged with the right hand side, to be averaged with 150 to 350. Okay, so the way to do this, so my technique is to create another array called xbin, and then I will do the bins colon -1. So if I do the bins colon -1 is so if I type the bins here, so you got the numbers from, you got 11 numbers, right? But if I type bins and colon -1, so this means your last number in the array will be deleted. Okay, so from the 11 numbers, we're gonna have just only the first 10. But then if you try something like this, if you try bins 1 colon, okay, so here the first number here, it was deleted. So you have only the last 10 values of your bin edges. Okay, so what we are doing is we are going to do the average of the bin edges. So you can think about this term, this array, as the left bin edges, and you can think about this term as the right bin edges. So you do the plus, and you can times all of this by 0.5. So that means you are doing the average of the array. Okay, and then if you try to plot this graph again with the xbin, so here is what you get for the histogram. Okay, so you can have a play with a number of bins. You can add up the number of bins to be 20. You get the more smooth histogram. Or if you add up this to 100, you're gonna get another kind of histogram. So it's just like you have 100 bins, yeah, and this was represented by 100 points. Okay, so for example, if I choose to plot x bin p, and if I do another plot with x bin p, but I plot this with dots. Okay, so here is what you can see. So you can see that you can see the data points in here. Okay, so yeah, that is the end of the task number 9.